Okay, TGI is back. Happy Friday, everyone. Let me set things up. Okay, great. Everything seems to be fine. Let's get started. Cool. Good afternoon, good morning, depending where you are. And TGIP is back this Friday, and sorry, I there's something interrupt. Okay, I'll get restart. Good afternoon, good morning, everyone, depending on where you are. And TGIP is back this Friday, and we just have we postponed for 2 weeks because we have the first ever Pulsar Summit last week, and we had about like 30 plus 31 uh, presentations, and it has been a very excited event. And thank you if you have attend this conference, and thank you for participate into this conference. If you haven't, then the conference we already uploaded our talk recordings and as well as the slides. So if you would like to check out the presentations that you missed in the conference, feel free to go to the Pulsar website, and you are able to um, watch the talk recordings, and as well as all the slides that shared by the speakers. So in this is our episode 14, and we're continuing the conversations around Pulsar schema. We would talk about uh, Pulsar and Flink integration. Especially, we did a lot of schema related integrations with Flink. So you can easily use Flink Circle to query the event streams in Pulsar. As usual, I would like to get started with okay, I will share this link in the YouTube chat, and anyone would like to check the links, it's available in the chat. And just similar as before, we'll get started with a week in review. And this week in review is kind of pretty excited. Is we just released 2.6.0. Frankly speaking, it was released last week, and because Pulsar Summit was happening last week, and we didn't get a chance to talk a lot more on Pulsar 2.6.0 release. And I think it's a good time to kind of work through a bit about what's happened, what are the features that release in Pulsar 2.6.0. And I think we already wrote a blog post. The blog post is talking about what are the major features that related to Pulsar 2.6.0 release. And a lot of features I might already cover in kind of previous TGIP episodes, but I would like to share a bit more here. And mm, we can plan a kind of a dedicated episode talking about Pulsar 2.6.0 release, maybe a webinar, but depends on how we are going to plan this. And let's take a look at the what's new in the Pulsar 2.6.0 release. I think one of very exciting features that came into 2.6.0 is large message support, and that is contributed by Rajan from Verizon Media. And the feature is basically for people who might already playing around with Pulsar, and there's a limitation about how large a message can be. And right now, by default, is 5 MB. And for sure, people can kind of increasing the setting, but it's not a very I/O efficient. Is because in that moment, if you increase the default setting to a very large setting, the whole broker bookie need to send the whole message as a whole batch into through the network, go to the disk. It's not very I/O efficient, and there's always a limitation about how large it can be support. And this change that was introduced by PIP 37 is to support producing and consuming very large messages. And Pulsar client would automatically split the large messages into multiple smaller chunks. And the library also make sure when the consumer consume the messages, it would reconstruct the whole message back from those chunks. And this would making sure uh, the client transmit all the packages and as well as write the packages into disk in a very efficient way. And it can pipeline all the data in like small chunks into broker, and broker can write those chunks into bookies. So if you have a requirement on supporting large message size, definitely check out 260. Namespace change event, that is, I think we covered that before. That is basically supporting capture all the changes for a given namespace. Pluggable metadata interface. We already have the metadata interface in place. In it kind of take Pulsar into next step to support a different type of metadata storage like etcd integration. We already did the etcd integration in BookKeeper, and we just need to add similar integration for Pulsar as well. And as and at some point, removing ZooKeeper, that is the goal for this pluggable metadata interface as well. And I would like to spend some time talking about this acknowledgement at batch index level. It's a kind of a great change, very great change. Is for people who know a bit about the acknowledgement model within Pulsar. The acknowledgement is the consumer can send the acknowledgement based on individual messages. However, the acknowledgement tracking at the server side is in the entry level. So basically, it only track the acknowledgement on individual batch. So if you use batches, and you might send a message to the broker, acknowledge to the broker, but the broker can only acknowledge or only write acknowledgement when all the messages of a same batch are all acknowledged. So this is kind of a drawback for Pulsar, because it would result in redelivering individual messages. Um, in in 260, we introduced this support acknowledgement at the batch index level. So it's able to track acknowledgement on individual messages. So you don't need to worry about that you only acknowledge a single message, but the other message in the same batch is not acknowledged. But when the broker crash or the consumer crash, then the acknowledged message will be delivered again. So this will solve a lot of weird, strange, I would say strange behavior you saw before in Pulsar consumer. There's a lot of these features. I'm probably not going to more details, but uh, there's a couple more. Is the starting from 260 with kind of supporting SN routing, so you don't need to just use rely on Pulsar proxy. You can use any other proxy mechanism like Apache traffic server, HA proxy, Ninjax, and Envoy, who support these SNI routing. That you can also use those proxy technologies on support as Pulsar proxy. And the other one is advertise multiple address. That is very useful if you don't want use proxy, but you want to expose a broker cluster outside of Kubernetes environment. You can use these to set up advertise multiple address. Like you can have a broker advertise internal address that can be used within same Kubernetes cluster, but you can also that broker advertise an address that is a public facing address. So you don't need additional proxy to set up your Pulsar cluster. So a lot of features, and since this episode is not about 260, I would just like give some highlights, and we can spend some more time like by having a dedicated session for 260. But if you are exploring Pulsar and looking into what's new in Pulsar, so definitely read this blog post. It has a lot of information and a lot of details about individual features we introduce for 260. And this is for project, and that is kind of a huge step for the whole community. And thanks everyone in the community for making this great milestone. And as I mentioned last week is Pulsar Summit. We have a wonderful 2 days with 31 sorry with yeah with 31 sessions that was delivered from different companies and that might spread across the globe. We have companies from North America, we have companies from Europe, we have companies from Asia that all speak about like how they use Pulsar in production and what are use cases and what is the best practice. So all the recordings are already available in the schedule. So if you just go to the Pulsar Summit website and click the schedule, and you would be able to see that there are two buttons here for individual talk. Then you can just click this link, and then it will show the individual presentation. And if you just want to check the slides, and you can just click the slides, and it will take you to the slide shares link. And you can go through all the presentations and find the one you are interested most. And yeah, and if there are probably some presentations the slides are missing for some presentations. We're still following up with speakers to see if we can get the slides and publish the slides in the Pulsar Summit website. So this is like Pulsar Summit. And the last one is so we actually so for a lot of people who asking like where they can follow up about the news of Pulsar as well as Pulsar Summit, then you can just click the subscribe link, and you'll subscribe to a newsletter for things related to Pulsar and Pulsar Summit. And you can also find the link in here. You can sign up in the Pulsar Summit website or go down to the newsletter button to sign up the Pulsar newsletter. And it has been very it has been a great couple of weeks. Uh, uh, it has been great in the Pulsar community in the last couple of weeks, and we hope that with the Pulsar Summit and the new release and can give more people about what is the current growth of the Pulsar community and what is the status of the project. And related to Pulsar Summit, we are I know we just finished the first version of Pulsar Summit, and but we already kind of started planning our special edition for Asia time zone. Because for the first Pulsar Summit, we many cover like the U.S. North American time zone and European time zone, and we are thinking of having a Pulsar Summit Asia like 2020 for around like late September or October, and that would be targeting for people like who is based on Asia Pacific. And more news would coming out in next couple of weeks. If you're interested in submit any talk to Pulsar Summit Asia 2020, then follow us at Twitter or like subscribe to our YouTube channel. I would also share those news through TGIP. Uh, yeah, so excited about all the momentums in Pulsar community. So this is kind of a overview about like what has happened in the last few weeks. And let's move to talk a bit about the Pulsar-Flink and integration. Especially that is an episode that continues all our previous episode talking about Pulsar schema and as well as Pulsar schema, how Pulsar schema was used in Presto integration. And in this episode, I would cover how Pulsar schema was used in Pulsar-Flink integration. So to get started, I would kind of start with a presentation I did before to talk about Pulsar and Flink um, integration. And there are also a bunch of reference links I put in the show notes. That is the um, like two presentation I made in uh, Flink Forward in 2019. And it covers all the aspects that how we do the Pulsar Flink integration and what is the like what are the how the source and sink are implemented and how Pulsar schema was integrated with Pulsar Flink. Those are kind of great content for you to check as well. Okay, so now let's talk a bit about Pulsar and Flink integration. So before that, I would talk a bit about history about Pulsar Flink connector, and so to give people a kind of an idea what exactly the current state of Pulsar Flink integration. And initially when we introduced this Pulsar Flink integration, we did this in the Pulsar main repo. Uh, the Pulsar main repo also kind of maintain an old version of this Pulsar Flink connector, and it's an integration with Flink 1.6. So it's a very old version, and it only does very simple integration, making Pulsar as a source and sink. And the source and sink is it was not designed for exactly once, and it doesn't has the schema integration, and as well as the bunch of other kind of the thoughts behind um, making Pulsar in Flink integration more smoothly. And right now, this connector is deprecated in favor of using a new Flink Pulsar connectors, and that one is the one is proposed by StreamNative to be contribute back to the upstream Flink up to be to upstream Flink. So that is kind of the it's contributed as part of Flip 72. Flip is Flink improvement proposal, and this it covers all the design of this Flink connector, and as well as the schema integration between Flink Pulsar schema and Flink types, and as well as the catalog in circle client integration. It track sorry, the design doc is also available here. So if you're interested in dig into more details, you can also go to this design doc and to check about all the details of um, this design. And as well as I think we already submit a bunch of the pull requests to Flink, and there's also a discussion. And for people who are interested in this, uh, for helping the community moving, making progress on this flip, feel free to kind of comment in this email thread and as well as the Jira ticket. So if you would like to see that happen, I would recommend kind of making a comment in the Flink ticket, and so we can work together with Flink community to make this connector officially available in Flink release. Okay, so and then that is the kind of the Flink connector that is being currently used in a lot of internet companies for building their Flink ETL pipeline, Flink job pipeline together with Pulsar. Um, so this is kind of a simple introduction of the background of a Pulsar Flink connector. And let's take a look at a bit how we design these Flink and Pulsar Connect integrations. And I'm using one of my presentation I made before about like building a streaming data warehouse using Flink and Pulsar, and hope that give you this presentation already walked through bunch of the details about how we integrate with Pulsar and Flink. So for a lot of people who might already get familiar with Pulsar or get play around with Pulsar, even like watch some of our episode before. And one of the idea we have been emphasizing a lot is the concepts within Pulsar is the basic structure, data structure is an infinity event streams, and how to kind of present that idea is um, a lot of people know Pulsar is a pub-sub system, and the entity of storing the master's topic. And you can interact with topics using pub-sub API. So you can have a producer producing events to a topic and a consumer consuming events from a topic. And a topic is kind of divided into multiple partitions. And the partition can be assigned to a consumer to consume via like exclusive failover subscription. A partition can be shared, consumed by a group of consumers through shared subscription or key share subscription. And for individual kind of partitions, each partition is divided into segment, and each segment is stored as BookKeeper ledger in BookKeys are stored as a blob in blob storages. So this is um, kind of segment is a unit of data storage and as well as data distribution. And so as you can see here, the fundamental abstraction is actually event streams, which is kind of a segment-centered event streams. And so a stream is comprised of multiple segments. And if you append into a new streams, then it would trigger load over a new segment. And so if you keep appending more events into the streams, and you would generate more segments, and the segments can be evenly distributed across the storage node within BookKeeper. And each segment can also be offloaded into a tier storage. And there's no limitation about how large what there's no limitation about the storage capability of a single stream. So you can just add more storage node to support more data. And so this is kind of the whole presentation that the data presentation that Pulsar present to client. It's an infinity event stream, and the data kind of the data at different age, at different stage or with different ages is stored in different type of storage. For example, most of the latest of data is cached in Broker. The warm data is stored in the bookies, and the cold data is stored in tier storage. So with that being said, is you have data that is spreading across different type of storage system, and that is used for serving the best purpose of different workloads. For example, if you are kind of using PubSub, you would always uh, most likely you would consume the data from brokers because it's for any PubSub messaging system, you require you push the data as fast as possible from producer to consumer. So caching the data in the broker would reduce the kind of latency. We're making sure once the message is produced, then it can be pushed to the consumers. And all the warm data in the bookies is because bookie is a fast append only like a faster log storage, so it's able to support um, append the data and making sure data is durably stored in bookies and is able to serve those like uh, large range scan and as well as point lookup for individual messages as well. And on the tier storage is most of the data that's stored in tier storage are historical data. And your application that will be looking for there is scanning all the historical data to do batch processing to do a backfill. So you backfill your system by scanning all the data from the first messages which might already start in tier storage. So this is kind of the way how Pulsar present the idea. The whole idea is the infinity event stream storage. And this stream storage infinity event stream presentation is actually provide a unified view on data. So because it's a stream, it provides PubSub, so you can process the data in the streaming fashion. Because the stream is also divided into individual segments, and the segment is spread across the storage node as well as uploaded to tier storage. So you can access the data using a segment reader, and this would making sure you are able to process the whole historical data in a very fast fashion. So this is provide two different way to access the data. One is PubSub, which is a streaming way. Segment reader is a kind of the batch processing data in the batch way. And this is what we usually call it's a two-level reading API. The first level is the PubSub. I think that is what a lot of people is using today. Is you are able to read the data directly through brokers, and you are able to using consumer to consume. You open a reader, you to read from a given partition, and it also supports different type of subscription mode, failover, share, key share. And if you want to reprocessing the data, you just rewind the cursor by seek the cursor into a given positions. So this is the streaming API. In a lot of cases, I want to accelerate my backfill process. I want to process the data that's stored in tier storage, and in that case, then segment reader would be the best choice because the segment reader you can read the segment in parallel, and as well as you can do predicate push down, and that would accelerate the process for processing the data in parallel. And this is kind of the when from Pulsar is a data system. So from a data presentation perspective, we are building these infinity event stream abstractions. But when you integrate with a data processing engine, what you are looking for is this data system able to provide a unified data access for the stream processing engine? And the answer is yes, because it's an infinity stream. You are able to kind of start up your processing from a given process and reading the data in a streaming fashion. And also you can, if you just limited the data you want to scan, this will become a bounded stream, and the bounded stream will be converted into reading many different segments. So this would be or became the kind of a unified sorry, this would actually provide a unified view for the data processing engine, and data processing engine can leverage that to do both batch and stream processing. And there's a uh, right now, most of the integration is kind of done with either using the segments only or using PubSub streaming only. But at some point, the integration should be done in a very smart way. Is for because Pulsar is a stream of segments. For the latest segment is you can always read the latest segment in the streaming fashion, but for the old segments you actually can read those segments in parallel. That can accelerate the processing if you kind of backfill or rewind your data processing into an early point. And one of the kind of the reason for when we explore the integration with Pulsar and Flink, we are not just thinking about Pulsar is just a source or a thing for building out the integration with Flink, but actually Pulsar has more. Pulsar is it's a data system, and the event stream stored in Pulsar is actually a structured event streams. And the structured event stream is basically each topic is associated with a schema. And I think we already covered a bunch of the schema talk in previous present like episode. Then we can just skip this session. But just the idea here is with schema as a first class citizen, Pulsar is not just mastery pipe. It's actually event stream storage with structure. So once you have the structure, you can do a lot of amazing stuff, especially when you integrate with a query engine or data processing engine like Flink here. So in the sense, how when we I'm not going to talk about how we kind of building the source and sink. because building a source and sink, there's many ways to building source and sink. Is for example, in our initial like integration, we just use the consumer interface to building the source, but it's not a very efficient. And it's not the best way for integrating Pulsar together with Flink. So when we do the second iteration on integrating Pulsar in Flink, we kind of step back and think about what is the kind of the value that Pulsar can provide to Flink, and that it comes to the idea how about bring the schema into the picture, and when you bring the schema into the picture, you actually can map Pulsar schema to Flink types, and that bring together the concept of Pulsar stream can be mapped as a Flink table in the Flink ecosystem or Flink catalog system, and that is kind of the idea we tie Pulsar stream together with Flink table. So in the most interesting thing here is uh, you need to, in order to make this integration become very valuable, we need to map Pulsar schema into Flink type system. Basically, individual messages will become individual role within Flink table. So the first thing we need to do here is how we convert the schema into a mastery with schema into a Flink role. And what we did here is for topics for streams that without schema, with primitive schema, we convert the mastery payload into a value. And for any uh, topics that we struct schema like Afro JSON, we convert individual fields and types into the fields in types and map the individual fields in type into Flink fields in types. Besides that, each mastery also contain a lot of metadata fields like key, topic, mastery ID, publish time, event time. We convert those fields into individual uh, metadata fields. So once you have this concrete mapping, that means individual master can be treated as individual role within Flink. And that once you have this mapping ready, then you can seamlessly integrate with the Flink catalog, Flink um, type system, and then you can leverage all the tools that are available in Flink. And this is kind of the two example that shows the kind of the how we map the schema, Pulsar schema into Flink row. In the left side is a topic that with primitive schema. So you see there's only a value and that bunch of metadata information. And in the right side, it's the alpha schema. So uh, individ um, so it's a structured schema with nested structs. And when we convert this alpha schema into a Flink table, we map individual field into individual field for a given row. So as you can see here, the struct is full and they have two fields, I and F, and a nested struct is called bar. And there are two fields in bar struct that one field is B and the other field is S. So when we convert this into a table, then this will become individual fields into this table. And we still keep all the individual metadata here. So this is kind of the how we convert the Pulsar schema into Flink types. At the end of this session, I will show two examples and hope that will give you a more concrete idea how this schema conversion is done in Flink. And so this is kind of the core idea. So I think there's bunch. It provides the capability for you to write source, write a streaming table. You can also make it use as a sink. So then you can convert a struct into a row and write to Pulsar. And this is just how you can program using Pulsar-Flink connector. And there's a lot of examples available in the GitHub repo. So you can just check out the examples and follow the examples there. And the one the most important thing I want to uh, kind of talk about here is about the Pulsar catalog. The catalog is very similar as what we did in our last episode. We talked about uh, Pulsar and Presto integration. The Pulsar Presto integration is basically making making Pulsar as a catalog for Presto. So Presto query engine can query the Pulsar topics. And Flink catalog is very similar. Is we are making Pulsar as a catalog for Flink. And once you have the register Pulsar as a catalog for Flink, then you can use Flink SQL to query the Pulsar streams, either in a streaming fashion or using in a batch fashion. So you can just write streaming queries as well as batch queries over Pulsar streams, and you don't really need to write your own program. And that is kind of the purpose of integrating Pulsar seamlessly with Flink. So you don't need addition kind of uh, system to kind of dump Pulsar into maybe like Hive or any other system, and then that Flink to query those system again. So this would be a kind of direct seamless integration for Pulsar and Flink. And I can go back to kind of walk you through about Pulsar catalog. So we already have a lot of instructions available in Pulsar-Flink repo. And here I will just actually let me pull the window here. Uh, okay, so uh, Pulsar-Flink, actually let me find the repo. Okay, so Pulsar-Flink already have a lot of instructions about how you can do the integration and how you can build the application using Pulsar source, building your application using Pulsar Sink, and as well as how to register Pulsar as a catalog. So you can just check out the program, but please make sure if you want to try this Pulsar catalog, make sure you're using Flink 1.9 because there's some changes between Pulsar Flink 1.9 and 110 as well as 111. So if you are using Flink 110, the current code probably doesn't work because there's some interface changes in the Flink catalog API. But the good news is there's an ongoing efforts that we are working with a company called Beagle on upgrading this Pulsar Flink integration to with Flink 1.11, and I think 1.11 is a very uh, amazing release for Flink that is all the Blink changes, like all the optimization for batch processing are already available in Flink 1.11. And if you want really enjoy this unified batch in stream processing, 1.11 is definitely the version you should check out. But in for this episode, I'm just using 1.9. So basically, what you need to do is you just need to build a connector, and I think we also published the connector as to our Maven repository, so you can also just download that jar to use. And once you download the oh, okay, I'm in the wrong one actually here. So this is the remote. Yeah, so this is the repo I download, but you can also check out and just build yourself Maven clean install, and then you will get a connector jar, and that jar then you can be used for running the catalog. And after that, you need to download the actually here. You need to download Flink 1.9. In this 1.9, it already provide the Circle client, and in order to run that, you need to configure one configuration for in Flink that is called Circle client defaults. That default is basically you need to register Pulsar as a catalog for Flink Circle. And if you go down here, is you can see I already kind of define a catalog, and the catalog name is called Pulsar, and the type is Pulsar. Uh, you need to map kind of a default database to Flink. We are using tenant plus namespace as the default database. And a service URL basically tell the connector where to talk to, which post cluster it should talk to, and the admin service URL as well. And there's a concept called startup mode, means when you run a Flink circle query, whether whether you should start from the earliest of this topic or the or from the latest of the topic. So this is startup mode, and you can for sure change this startup mode for individual queries as well. And if you are doing the insert queries, like DDL queries, and you will need to define a table default partitions, this would tell the connector when you create a topic what is the number of the partitions that you should be used for creating the parser topics. So once you have that, you're done with the configurations. There's no more configurations, and then you can run this Circle client, and this is run the Circle client in bad mode. But you need to supply a jar, and the jar is the one I just built from Pulsar-Flink repository. And why do you need to supply the jar? And because you need to making sure when the Circle client started, it will look up for the catalog, and you need to find the catalog available. And the catalog implementation is bundled as part of the Pulsar-Flink connector. So you need to specify that in the Circle client. So once you started, you would get kind of a very like great like a circle like a command line, and then the next thing is you need to start a Flink cluster locally as well. And I'm not going through that process at this moment. Um, once you have this Flink Circle client running, then you can just show catalogs. You will see there's a catalog Pulsar available, and that catalog is the catalog that we just defined in that configuration file. And once you have the catalog ready, you can just use catalog Pulsar, and that basically you switch the so you make Pulsar as the default catalog for the subsequent command. Then you can just run show databases. So as you can see here, the show databases is basically go through all the listing out all the tenants and namespace of a Pulsar. Because we map individual namespace as individual database within a Flink catalog. So as you can see here, I have two namespace. One is public default, the other one is public functions, and those will become the databases. And then since I already config public slash default as a default database, then I can just, assuming I already use that database, then I can just show tables. So this will show all the topics as the tables in Flink. So if I go to, I just used Pulsar client, the main client, I can show topics list public default. So you can see I have four topics: word count output, output topic, input topic, word count input. Those four topics are shown as four tables here. And we can also describe the topic. Sorry, describe a table. Let's say input topic. So this one is kind of a uh, it's the input topic is a prim is a topic that is using string as a schema. So as you can see here, the value is actually be select as so be mapped as a string field in Flink, and all this metadata is also attached there. So if we want to take a look at a bit more about this input topic, so we can check, we can run select input topic. So as you can see here, yeah, so this input topic, I think my screen is too large. Actually, let me run this again. So as you can see here, um, the value is a string, and because this topic that this message doesn't has key, so it's null. And the topic is coming from, this is a fully qualified name. This public slash default slash input topic. And this is the master ID. And master ID is converted into a blob, and as well as the publish time. And because we didn't attach any event time for this, so this would be the event time. So this is a kind of stream inquiry. So if I produce a master here, let me see. Produce hello from TGIP episode 14, and this would be input topic. So I produce another one, and then you should be able to see. It doesn't show. Did I use the right name? Interesting. Oh yeah. So this is the new one. Yeah, the mastery I just produced is the hello from TGIP episode 14, and this 14 because it's a bit wrong, so it kind of cut the string, and this is produced in yeah um, 1:53 p.m. So like it's the latest one. So this is kind of the topic with string schema. Then let's take a look at another topic. That topic is I already created before. That is a topic with Avro schema. So we can see uh, admin topic, sorry, schema get. Oops, schemas. Oh. So as you can see here, the word count output is a schema, and it has two fields. One is word, the other is count. And let's run. I can describe this topic again. Describe word count output. So as you can see here, this field is a bit different from this field. It's because the schema of word count output is the Avro schema is a struct schema. So when we convert the struct schema into a Flink row, we map individual fields as the fields for Flink. So when you describe this topic, you will see that individual fields here. And if we select this from you should be able to see this is kind of the messages within this topic. And as you can see here, this is the word, this is the count, and bunch of the other metadata information is also available here. And let's show a bit more is the topic was actually reading from an input topic called word count input, and run a Flink job to do streaming word counting. And I can run this job again, and then we can see how it looks like. Once this job is running, I can try to produce more master to the input topic. Oops. Yeah, here. So I produce 100 messages into input topic. So this input topic is the word count input. So when I produce this 100 messages to this word count input, there's a Flink job would do the would process that and generating new commands there. Sorry, let me actually see if the job is running. Job should be running. Uh, and it should be a window. I'm not sure. Oh, okay. So it refresh again. So you can see here new kind of word count result would be coming. So if you keep it's a kind of a streaming query. So if you keep like producing more mastery into income input topic, then the Flink job would do streaming word counting and produce the result into output topic. And this circle query is basically updating that uh, that output topic. Sorry, the circle query is acquiring the output topic, and it's also a streaming query. So you would keep receiving the messages from the this query. So this is basically what I want to show a bit about to help you understand a bit more about the Flink in Pulsar integration. The Flink in Pulsar integration is not just about making Pulsar as a source and sink for Flink, but we are actually doing more by integrating the schema deeply with Flink. So Pulsar can become a catalog of Flink. So once you have this catalog mapping ready, then a lot you can use Flink to do a lot of BI and data processing, machine learning, and a lot of these analytic jobs. So this is all the kind of the sharing for today, and I would definitely encourage people who are using Flink, definitely try out this Pulsar Flink connector, especially using Flink, using Pulsar as a catalog for Flink. You would enjoy the full power of schema as well as this streaming circle query provided by Flink. And that's all of the episode for today. And if you are interested in more about this Pulsar-Flink, feel free to reach out to me. And if you like our TGIP uh, weekly live stream, uh, feel free to give us send emails to us and send feedback to us so we know how to improve in future. And thanks everyone for attending this episode. And happy Friday and happy have a good weekend. And we will see you in next episode. Bye bye.